Okay, so this is the finding x trick. It is, again, just based on your de Mesmer method. However, it's got an extra little step at the end you need to kind of bolt on to the end of it. So if you're asked to find x, where x is either an element, or it could be the number in the water of crystallization, like .xH2O, it could be that as well. What it's really asking you to do is find the MR. Because if you know the MR, you can look at the periodic table and figure out what element it is. So in a finding x question, this last moles equation here is going to start MR equals. That's the first thing to realise. So you're going to go through the standard method, you're going to get your MR of the whole thing, of the whole compound, and so you will know, as an example, let's say we have XCl2, you will know your total MR, because that's what you'll do using your standard method. All you then need to do is slightly rearrange. If XCl2 is the total MR, answers on the whiteboard please. X will be... So you're going to do this one. You're going to do a nutrient. So all you do is just stand for those. Find the total MR of the whole thing. No. Yes, excellent. Very nice, yeah. Yeah, you've even put a number in, very good. Yes, but you've used the proton number, not the mass number. It's the big number, yeah. Yeah, absolutely right, guys. So it's going to be your MR total minus the MR of everything else, which in this particular example would be the MR of Cl2. Obviously, adapt that to whatever question they give you. So that's really it, and that's the most common version of this. Do your de Mesmer to find the total MR, subtract the MR of everything else in the equation, and you'll be left with the MR of X. Just look at a periodic table and see which one fits. Now be aware, because of experimental error, it might not fit exactly. So let's say, for example, X was carbon, right? So carbon should be 12. You might end up with 11.8, right? Because of experimental error. So just pick the most sensible answer from the periodic table. What do you think? Yeah. There's a second kind of variation of this. It's basically the same, which involves water of crystallization. So I don't know, as an example, let's say I've got FeSO4.xH2O. Would you agree that this is in the form salt.xH2O? So I'm just going to replace this with the generic word salt. Whatever your salt is, look at the question will tell you. It'll be something like iron sulfate or copper sulfate, something like that. Now, in maths, the way this works is it's salt plus X times H2O. That's like the mathematical way of saying that. So again, if you get this and they say find what X is, obviously X will be a number now, do your standard de Mesmer, find the total MR using the standard method. So you can say salt.xH2O, whatever the salt is your total MR. Again, bearing in mind that this is the maths version of that, can you rearrange that to get X equals? Try on a whiteboard. No, it's just an extra step. At some point today I'll come over and I'll go through it. Excellent, exactly. Yeah, exactly. Get your boards up, let's see what we got. Very nice, you guys are on it. So, first of all, we're going to subtract the salt. So our XH2O will be MR total minus MR of the salt. And then as it's X times H2O, we need to divide by the H2O. So X is your total MR minus the MR of the salt, basically divided by 80. H2O. In this equation here, get it on a flashcard. That is definitely worth banging on a flashcard because you're going to need to use that and you don't want to have to figure it out every time. Although you can do if you need to. Yeah. That's how you find out.